video is about adding and subtracting fractions. So we're going to start by adding fractions, and first I want to point out the steps that I have along the side. First is finding a common denominator. Second would be adding the numerators. Third, keep the denominator the same, and then simplify if possible. So let's go through how to do that. Alright, so right now we need to check to see if our denominator is the same. So we're looking at that 5 and that 5, our two bottom numbers. They are the same, so we can go ahead and go on to the next step, which is adding our numerators. 3 plus 1 is 4, and then the next step says keep the denominator the same, so we're going to keep our 5 the way it is, and then simplify if possible. There is nothing that goes into both 4 and 5 evenly, so that's my final answer. Alright, so another one. Finding a common denominator, looking at my 4 and my 5, they are not the same. So I do need to find a number that they both go into evenly. My best bet here is going to be 20, so I need to actually change these. So I'm going to set it up so that I can get a denominator of 20. I'm going to use my giant 1. And then I'm going to do the same thing for my second fraction, 3/5. Again, I want a denominator of 20. So I have 4 times what is 20? 4 times 5 is 20. So whatever I do to the bottom, I need to do the top. 1 times 5 is 5. And then down here it is 4 times 5 is 20. So we need to do by 4 on the top. 3 times 4 is 12. So my new problem becomes 5/20 plus 12/20 and my denominators are the same, so I can go ahead and add my numerators. 5 plus 12 is 17. And then I'm keeping my denominator the same. Simplify if possible. 17 out of 20 I cannot simplify to make even numbers, or nice whole numbers I should say. So 17 out of 20 is my final answer. Alright, and my last example. We have 6/7 plus 2/3. And here I don't have a common denominator looking at my 7 and my 3, so I need a number that they both go into. So I can just multiply those together to get 21, so I think that'll be my best common denominator. I could find a higher one, but I want to stick to a lower one if I can. Lower common denominators would mean less simplifying in the end. So 21 is what I wanted out of. And then I have 2/3 here. And I want to get this one out of 21 as well, using my giant 1 to make sure I have equivalent fractions. 7 times what is 21? That answer is 3. So 6 times 3 is 18. And here 3 times 7 is 21, and 2 times 7 is 14. So my new problem is 18 21st plus 14 21st. 8 and 4 is 12, so I'm going to put the 2 there, carry my 1, so I have 1 plus 1 plus 1 is 3. So I have 32 over 21. Now this one happens to be an improper fraction, so I can definitely simplify this. And I want to know how many times 21 goes into 32, and it goes in once. And I'm going to do 32 minus 21, and I get 11. And that's a good way to check too, to make sure that you did your math correctly. If I had come up with a number over 21 here, I would know that I could put it in twice instead of just one, but 1 is my answer. And I cannot simplify 11 over 21, so that is my final answer, 1 and 11/21. So now we can move on to subtracting fractions. This is very similar. We're going to do those same steps, only this time instead of adding our numerators, we're going to subtract. So I did a very similar one here, 6/7 and 1/3, so taking away 1/3. So I already know that I am trying to get to 21. So I'm just going to set that up really quick. Times 3, and I get 18. And this time I'm doing 1/3 instead of 2. Ooh, that doesn't look like a 3. Alright, 1/3. Setting up my giant 1. Getting it out of 21. So now I have 7 out of 21. So my new problem is 18 out of 21 minus 7 out of 21. Now I have a common denominator. I can go ahead and subtract my numerators. 18 minus 7 is 11. Keep my denominator the same. I have 11 out of 21 and I cannot simplify, so that is my final answer. Alright, then we have 2/3 minus 1/4. My denominators are not the same, so I'm looking for a number that both 3 and 4 go into evenly. That number is going to be 12. So I have 2/3, and I'm going to set it up with my giant 1 to get it out of 12. And 3 times 4 is 12, 2 times 4 is 8. And then I have 1/4 that I want to get out of 12 as well. So 4 times 3 is 12, 1 times 3 is 3. So my new problem is 8 over 12 minus 3 over 12. And now I have a common denominator, so I can subtract my numerators. 8 minus 3 is 5. Keep my denominators the same, and I get 12. There's my final answer, 5 out of 12. I cannot simplify. Alright, so here is an example with mixed numbers, and in order to subtract, I actually want to turn this mixed number into an improper fraction. In order to do that, I need to do 4, because I have 2 wholes, and my wholes are out of 4, so I do 4 times 2 and I get 8, so I'm going to add that 8 on to the 3. So 8 plus 3 is 11/4 minus 2/5. I do not have a common denominator, so I do need to get this out of, again, 20. So I have 11 over 4, and I want to get that out of 20. So I'm going to do 5 here. 4 times 5 is 20, 11 times 5 is 55. And then I have 2/5 that I would like to get out of 20 as well for my common denominator. 5 times 4 is 20, 2 times 4 is 8. So I have 55 over 20 minus 8 over 20. So I have a common denominator. I can go ahead and subtract. So I have 55 minus 8. I need to borrow. So I have 15 minus 8 is 7. And then I have 4. So I have 47 out of 20. And then I can go ahead and turn this back into a mixed number because I do not want an improper fraction as my final answer. So 20 goes into 47 two whole times. And I can subtract. I need to do two groups of 20, which would be 40. So I have 47 minus 40 because I need to take away those two wholes. And I get 7. So I get 2 and 7/20ths. And I can't simplify any further. So that is my final answer.